So, 5-7, last section in Unit 2. Quadratic inequalities. We're going to put two of our favorite things together here. Graphing parabolas, and now dealing with having to shade on these. You've probably done shading before with regular linear equations, where you have the line you figure if you're shading above or below. Now with the inequalities, of course, we don't have above and below because it's a parabola. So instead, we're going to be figuring if we're shading inside the parabola or outside. But it's a pretty easy process to get you there. So, while we're doing these, a couple things to pay attention to. Should the function's boundary be solid or dashed? Easy answer to that question. If you think back to when you were doing it with lines, solid was when we had the or equal to. So if you see less or greater than or equal to, that's going to be a solid line parabola. If we've got a, oh, I'm sorry, I didn't see your pencil. I'm sorry. I thought you needed a new pencil. People online are going, what is he doing right now? I'm making misjudgments on people needing writing utensils. Okay. Or dashed if it's just greater than or less than. Okay? So that'll be the first thing that we can pay attention to. How do we graph that particular quadratic? Sometimes if they're in standard form, we may have to find the vertex. Other times, if we understand what our mother graph should be, we might just have to do a quick shift, and it won't take us long. And we can always go to the calculator as a background if we need to. And then finally, where do we shade, inside or outside? My favorite way to know for sure is to use a test point. Okay, but we got to make sure it's not on the parabola. And I'll explain that when we actually get to doing our first one here momentarily. So graphing parabolas, okay? Couple of things that we're going to base off of. And again, with this first one, we're going to treat it just as though it were y equals x squared. Well, when we had y equals x squared, that was our actual mother graph for quadratic. So if we remember back for just a moment, we'll build off of this. We'll get to a point where maybe we won't even need to do this part. When I worked these before, I know that my graph started at 0, 0. And we were always looking at two values less and two values greater when it came to building these. So the nice part about this is, you're like, oh, x, 1 squared is 1, okay. 2 squared, because I'm just plugging it in for x, and I'm getting my y value out, is 4. And it's the same with my negatives, because I'm going to be symmetrical. So the quantity in parentheses, negative 1 squared is 1. And our quantity in parentheses squared of negative 2 is 4. And again, this is my mother graph. And this can really help me out if I understand where it comes from when it comes to graphing. Because if I understand the mother graph, when there are some basic shifts that get done, it'll keep this simpler to do. I can just shift up, down, left, right, or flip it, and then just keep rolling along. But again, here comes our difference, and I should have been careful, but I got away with it. Should my parabola have been solid or dotted? Solid, okay, I'm fortunate, because I'd forgotten about that for a second. So it's going to be solid, okay, and that matters because that's how we tell people, you know, if it's or equal to or not. So how do I figure out where I'm going to shade? Here's our deal. We're going to test a point. It can be anywhere on the graph except somewhere on my parabola. So let's just say, for sake of argument, I like this point. I like having 0 as one of my numbers. So in this case, I'm going to test the point 0, 2. You can test any point you wanted to. You know, if you wanted to test the point 10, 0, you could. So what we're doing is we're going to plug this into the inequality, and we're going to see if it comes out true or not. So if I test 0, 2, I go, okay, so let's see. Is the 0 or 2 my y value here? The 2 is. Okay, so if I plug this in, I have 2 is less than or equal to 0 squared. I'm just taking this and plugging the actual values in. So I simplify that, and I get 2 is less than or equal to 0. Is that true? No. Okay, that's false. Here's what that means. False means I shade in the opposite region of where I am. Since my test point was inside the parabola, and I got a false, in this case, that means I'm going to shade on the outside. That's where my solutions would be. So any point that I would pick outside of my parabola would make this a true statement. So like if I picked 10, 0, I'd plug in the 0 for y, I'd plug in the 10 for x, is 0 less than 100? Yes, it certainly is. So these are where my true statements are going to lie. But that's the easiest way I can think of to make sure that you're getting, that you're shading in the right place. Any value, any point on the entire graph except the points that are on my parabola. Any other point you can give a shot to. And you'll always get, if I were to pick any value inside the parabola, I'd always get a false answer in this case. If I were to pick any value outside of the parabola in this case, I'd get a true answer. So for instance, pick some point for me outside the parabola. Okay? Negative 2, 2. So if I tried this point out, okay, that's outside the parabola. So if I were to test out negative 2, 2, I'm still going to plug that into the same inequality. So my y value is 2, and then I'd have negative 2 squared, which is 4. Is 2 less than or equal to 4? Yes. So whatever area is true, that's where you shade. Okay? And if it's false, you shade in the opposite. Let's actually write that in here. That's a good idea. So true would be shade that place. And if if I'm testing outside and it's true, I shade outside. If it's true and I have it there, it's inside. And then false means we're going to shade the opposite area. And I appreciate the question because I want to make sure that we kind of get this. I mean, we have several examples to play with, but the more we can kind of jump in and get after it, the easier it's going to be when you're actually doing this. Now, for some of you that are having issues just with shading parabolas, period, okay, if you can keep an eye on what your mother graph should be, which would start at 0. If I look at the next one, I could make a chart, but let's think about this for a minute. That plus 4 is actually just the shift of my mother graph, up 4. So basically, what that tells me a couple of things. One, if I were to think about it as a chart, and I'd still have the same values, okay, I didn't shift left or right at all, basically what I'm going to do here is I'm going to take each of my y answers, I'm going to add 4. I'm going to shift them up 4. So this becomes 0, 4. 1 plus 4 gets me to 5. Thank you. And 4 plus 4 gets me to 8. And then just like we had down here, we're going to be symmetrical. So we just add 4 to every one of my y values. So when I go to graph it, and I'm looking at it in comparison to my mother graph, I'm like, I see how this works, because now the width of my parabola is not changing. Just it's taking this whole thing and shifting it up. Okay? Yeah, I was going to say I was smarter this time. This time I didn't make my line right away, and this time I see it's going to be dashed. Because again, if it's just greater than or less than without the equal to, that's how we signify that. So I've got a dashed line. Anyone care to pick us out a test point this time? I know where I'd go, but I'll... 0, 0. Nice pick. I like 0, 0 when that's an option. Because it clears stuff out. So if in this case I decide I'm going to test 0, 0 out, so I've got 0 is greater than, 0 squared is 0, plus 4 is 4. Is 0 greater than 4? False. So where am I going to be shading? Inside the parabola. Because I tested a point outside and got a false answer. Yeah. Aha, I see what you're talking about right here. Thank you. But yeah, otherwise I'm plotting the same point twice. That doesn't make a whole lot of sense. But that's what we're on the lookout for with these. And again, you hit any point you want as long as it's not on the parabola. So, now we got a couple issues here. What's going on in number 3? Okay. I see that I have to flip it, and I also see that I'm going to be shifting up 2. Now, a couple of suggestions. When you go to start doing these, I haven't done this yet. I've been trying to purposely avoid it to make sure that some of you don't get a little calculator dependent here. But you can, with these, actually let the calculator help out, especially if you have issues when you're graphing. You're like, ooh, to flip and shift. Okay, so let's just say you decide, okay, I'm going to get some help on this one. So I've got negative x squared plus 2. And I decide, okay, I'm going to graph this one on here. I knew it was going to open down because, well, it's got a negative x squared. I knew that it was going to shift up 2, and I see that happen. But I'm not quite sure where the points are right now, so how's this supposed to work? Okay? I can still go to second graph and go to my table, and I'm still going to end up being able to go from here and get my y values. Because knowing that 0 is where my vertex is at, I see symmetry. And we've talked about this before. If whatever's in the middle, I see the exact same numbers going above and below it, I know I've got the vertex in that case. So once I know that, I can go ahead and I can plot my points to get there. So if you're like, okay, but I don't have the calculator working at home. That's why we've shown you in the other ones how we can do it by just cranking it out. My x values aren't going to change. So even if I know... Two reasons that we don't use pen in math class. One, you can't erase it. And two, it makes it harder to cover up mistakes when your students find them. This is, oh, yet another reason we don't like the, dang, I'm learning my lesson, I'll try to remember to start using pencil, but I give them all away and I never get them back, so, alright. We're going to try and avoid this. You can see there's some points that we're just not going to use in this particular one. So now that we're dotted, because I've been corrected, we're going to look. Let's try. Oh, look. I was waiting for somebody to be a smarty and say 1, -4. Okay? Put my pen right in the middle here. Oh, I've heard so many good ones. My love for 0, 0 will not fade. Oh. 0, 0 is just great. It just makes life so much simpler. Alright, so we're going to test 0, 0. Anybody that's looking at this is getting a kick out of it at this point going, okay, this guy's nuts. Alright. That could be scary. 0 plus 2 is 2. Is 0 less than 2? True, so we shade the inside, because my test point's inside. So we have to pay special attention to where our test point is, because that matters. Because you're like, dang, sometimes it's true and it's inside, sometimes it's true and it's outside. It depends on where my test point is. Because before somebody mentioned 0, 4. If I tested 0, 4, that would have been outside false, which would have meant I shaded inside. It's the opposite. Okay? So not too bad so far, not too bad. But of course we have to throw a twist in. You know, it's always that way. Oh my. For these, yes, we're going to have some up and down shifts. I'm not going to mess with the left and right stuff. So now, here's the twist, though. What's changed with 4 and 5? Now we have an x with the second term. So we're going to deal with intercepts now. So basically what we're going to do here is, what do these two have in common? X. So if I take an x out, what do I have left? X minus 4. So we're going to treat this like we would a factoring problem. This is going to tell me what my x-intercepts are, because we've set those each equal to 0. So what would my two x-intercepts end up being? Okay, 4 and 0. So now I have x-intercepts at 4 and at 0. So I put those in. I believe so. So when I get that situated, anybody remember back when we were graphing quadratics with intercepts, how do I find the vertex now? Go in the middle. Okay, so my vertex, go in the middle. My x value is going to be 2, and then plug it in. So then my y is 2 squared minus 4 times 2. 4 minus 8 is negative 4. So my vertex is at 2, negative 4. Almost got sucked in again, even though I'd have gotten away with it. Is this one solid or dotted? Solid, because I have the or equal to. Okay. I don't need to be doing any more whiteouts here. So put my parabola in there. Dang, can't use 0, 0 this time. Okay. 2, 0, okay. Again, any point works that's not on there, but I like this idea. We keep finding a nice, easier point in the middle to work with. But again, yeah, when you plug these in, make sure, yeah, this is 2, 0. If I did 0, 2, that could be a little different. So let's see. 0 is greater than or equal to 2 squared minus 4 times 2. 4 minus 8 is negative 4. 0 is greater than negative 4 inside. They're like, this isn't really that bad. It's just several things working. No, I'm not making this any worse on the quadratic inequality. And they make me sound like this evil guy who just wants to sit there and cause them pain. So I'm an expert. I don't need the second example.
We do.
We do. What's this look like factored? X plus 3. So what are my intercepts? Okay, so my x-intercepts are at negative 3 and 0. They're like, ooh, Harty, this isn't going to be nice. Okay, yeah, my vertex, and again, you can either count to the middle, or you can always add your intercepts together and divide by 2. So basically, you're finding a midpoint. So my x value is negative 1.5, negative 1.5. And then again, to find your y, plug it in. I believe we end up with negative 2.25. So my vertex would be at negative 1.5, negative 2.25. And again, when you're picking these, try to avoid getting real close to the parabola with your point, because since we're not plotting every point that's possible on the graph, we could be off a little bit here and there. So like, I wouldn't pick as one of my options, like, just to be safe, I wouldn't pick like 1, 1 here. That could be a little dangerous, because if I'm off a little bit here and that's actually on the parabola, that could really mess me up. So any options, because we can't use 0, 0 again. What's up with this? Okay, 3, 2. We're out here a ways. That's pretty safe. So if we test 3, 2. Alright, so my y is 2. 3 squared is 9. Plus 3 times 3 is also 9. Is 2 less than or equal to 18? It is. So we're shading the outside. Because here, if I'm plugging 3 in for x, 3 squared would be 9, and then just 3 times 3 there. And then we just plug it back into whatever the inequality is. If it's true, shade there. If it's false, shade in the other place. Yeah, save the note sheet. We're going to be finishing these notes on the back on Monday. So the only part you're dealing with today, yep, 303, 14 to 16, and 18 to 20. We'll do the actual factoring way of doing this and combining it with that on Monday and talk about interval notation. So I wanted you to be able to get you this done in class.